Betelgeuse, the red supergiant star located at the edge of our universe, is sending disturbing signals through space. Cosmologists using the James Webb Space Telescope have uncovered something profoundly unsettling about this massive star. Renowned researcher Brian Cox has issued a stern warning, with the pressing question being, are we about to witness a cosmic explosion so massive it could permanently alter the night sky? To understand this, we must dive into the vastness of the universe. Stars are born, live, and die in astonishing ways, and recently, one star has caught the attention of astronomers and the general public alike. Betelgeuse, a red supergiant in the constellation Orion. This star is immense and ancient, with a striking reddish hue and varying brightness that have long intrigued skywatchers. However, recent events have intensified concerns about this celestial giant. What does this unusual behavior mean? Are we on the verge of witnessing an astronomical spectacle on an unfathomable scale? Betelgeuse is a stellar behemoth, roughly 10 times the mass of our Sun, and it is so enormous that if it were to replace our Sun, its surface would extend beyond Mars' orbit, engulfing Mercury, Venus, Earth, and Mars. This massive size not only highlights Betelgeuse's physical grandeur, but also marks its stage in the stellar life cycle. As a red supergiant, Betelgeuse is nearing the end of its life. It is expanding and cooling after exhausting the hydrogen in its core, a process that leads to the transformation of hydrogen into helium. At around 8 to 8.5 million years old, Betelgeuse may seem relatively young in human terms, but it is ancient by stellar standards, having undergone significant transformation. Initially a hot blue star, it has now reached its red supergiant phase, nearing the end of its life cycle. As stars like Betelgeuse evolve, they undergo changes due to the pressures of nuclear fusion and gravity, which drive their ongoing transformations. The star's reddish color comes from its cooler surface temperature compared to the Sun. While the Sun's outer layer is about 5,500 Kelvin, Betelgeuse's surface is only around 3,500 Kelvin. This cooler temperature causes it to emit light at redder wavelengths, giving it its characteristic hue. This color shift is not just an aesthetic observation but provides insight into the star's internal processes. Historically, Betelgeuse was noted as yellow in ancient Roman and Chinese records, but by the 9th century, Arabic astronomers observed its red hue. These changes are not merely a curiosity but are indicative of Betelgeuse's ongoing evolution. One of Betelgeuse's intriguing characteristics is its variability in brightness. As a semi-regular variable star, its luminosity fluctuates on a regular cycle. It typically undergoes a short-term cycle of about 6 days and a longer 5-year cycle, first documented by Sir John Herschel in 1836. Even ancient cultures may have noted these fluctuations in their own star lore. However, Betelgeuse occasionally behaves unpredictably, showing dramatic and unexplained variations in its brightness, suggesting that more complex and poorly understood processes are at play within its vast structure. This mystery deepened when, in late 2019, Betelgeuse began to dim unexpectedly, in what became known as the Great Dimming. By February 2020, it had become significantly fainter, and even casual observers noticed the change. This event raised alarms among astronomers, as Betelgeuse is located about 725 light-years away, meaning we see it as it was nearly a millennium ago. This time lag makes it difficult to track and interpret rapid changes in its behavior. The dimming event prompted intense observation from Andrea Dupree and her team at the Harvard-Smithsonian Center for Astrophysics. They conducted a 3-year study using the Hubble Space Telescope to examine changes in Betelgeuse's outer layers. Their research revealed that the star's outer material was moving into its atmosphere at speeds of up to 200,000 miles per hour. This material eventually formed a vast dust cloud that obscured the star's light for months. The study also found that Betelgeuse's mass loss was much higher than expected for a star of its size, raising questions about whether this could be a precursor to a supernova explosion. Given Betelgeuse's immense size and the scale of this mass loss, some scientists have speculated that it could be the beginning of a supernova event. If so, it would be visible from Earth and could provide a rare opportunity to observe such an explosion up close. However, it remains unclear whether this dimming is a sign of an impending supernova or just a temporary fluctuation in the star's life. Several hypotheses have been proposed to explain Betelgeuse's dramatic behavior. One theory suggests that this darkening is part of the supernova process as the star nears the end of its life. Another possibility is that dust ejected by the star itself could be blocking our view. Finally, some astronomers have considered the idea that changes in Betelgeuse's photosphere, its visible outer layer, could account for the dimming, especially since spectroscopic studies revealed a significant drop in temperature, possibly due to the formation of a dark spot on its surface. Whatever the cause, the mystery surrounding Betelgeuse's behavior has captivated both scientists and the public, raising the stakes in our understanding of stellar evolution and the fate of massive stars. The Hubble Space Telescope, humankind's vigilant observer in space, has finally unraveled a strange event on the surface of Betelgeuse. The star, which has long fascinated astronomers, showed signs of a massive release of hot material into space. This ejected material formed a dust cloud that obscured a portion of the star's surface, dimming its light. Scientists hypothesize that this cloud was created by extremely hot plasma ejected from a large convection cell on the star's surface. As it traveled outward through the star's hot atmosphere to cooler outer layers, it cooled and formed dust grains. This dust cloud blocked about a quarter of the star's surface from view. But what does this mean for the future of Betelgeuse? Could this be a signal that a cosmic explosion is imminent? Or is it simply an intriguing chapter in the star's long and complex life cycle? Hubble's bright light spectroscopic observations, which began in January 2019, have been crucial in understanding the events leading to Betelgeuse's dimming. These studies revealed signs of thick, hot matter moving through the star's atmosphere. Ground-based telescopes also observed the star's fading in December 2019, particularly in its southern hemisphere. At first, the expelled material was brighter than the star itself, but as it cooled and moved outward, it formed a shadow. The prevailing theory is that this outflow of material and the resulting shadow caused the sudden dimming of the star. The massive release of material, estimated to be about 400 billion times the mass of a typical coronal mass ejection, places Betelgeuse at the center of galactic studies. This event, involving material several times the size of the Moon, provides critical insights into stellar processes and Betelgeuse's behavior. This massive explosion challenges existing theories about the death of stars, particularly red supergiants like Betelgeuse. It raises the possibility that these stars might not lose mass at a steady rate before their deaths, but instead undergo more erratic and violent ends. Could this event be a precursor to Betelgeuse's final cosmic explosion? While such an explosion is a likely outcome for Betelgeuse at the end of its life, predicting exactly when it will occur is difficult. The star's distance from Earth, approximately 725 light-years, adds complexity to observations, as the light we see from Betelgeuse today actually left the star over 7 centuries ago. This time delay complicates efforts to track rapid changes in the star's brightness and other characteristics. The recent dimming event, which reached unprecedented levels of faintness, sparked widespread interest and speculation. Both amateur and professional astronomers noticed the star's significant change in brightness, leading to various theories about whether Betelgeuse might be entering a prolonged dimming phase or if the event was a temporary anomaly. In addition to visible light observations, astronomers used various telescopes and instruments to study Betelgeuse across different wavelengths, including ultraviolet and infrared. These studies provide essential insights into the star's atmosphere and overall environment, helping to piece together the complex processes at work in such a massive and evolved star. The dimming event also shed light on the mechanisms through which massive stars like Betelgeuse lose mass. Understanding these processes is vital for modeling stellar evolution and predicting the fate of other red supergiants in the universe. Betelgeuse's mass loss rate is estimated to be significantly higher than that of our Sun, highlighting the unique nature of stars in the late stages of their lives. Though this latest dimming event captured significant attention, Betelgeuse's variability is not a new phenomenon. Astronomers and skywatchers have recorded the star's changes in brightness and color over centuries. Ancient records from various cultures provide valuable insights into how Betelgeuse appeared and behaved in the distant past. These historical observations help deepen our understanding of the star's long-term variability and evolution. Looking ahead, astronomers will continue to monitor Betelgeuse for further changes. The recent dimming event underscored the value of long-term observational studies and international collaboration in astronomy. Telescopes and observatories around the world will remain focused on Betelgeuse, ready to capture and analyze any future developments. Studying Betelgeuse is not only about understanding the life cycle of stars but also about exploring fundamental astrophysical processes, such as mass loss mechanisms and the dynamics of supernova progenitors. Beyond its scientific significance, Betelgeuse holds a cultural and symbolic place in human history. Named after a character from ancient mythology, the star's prominence in the night sky has inspired artists, writers, and storytellers for centuries. Its distinct reddish hue and fluctuating brightness have made it a subject of fascination and wonder. In conclusion, Betelgeuse continues to captivate both astronomers and the general public with its dramatic changes and potential for a future supernova. The recent dimming event has drawn attention to the star's dynamic nature and raised important questions about its evolutionary path. While much remains to be understood about Betelgeuse's future, ongoing observations and advancements in astronomical technology promise to uncover new insights into this colossal star and its role in the universe.